So another vectors example. This is adding parallel and perpendicular vectors. So we read through and we see that we're adding up a whole bunch of different displacement values. So we got, here we are, it's 11. Okay, so we've got a whole bunch of numbers. What we could do is we notice that they're all on north, south, and east-west directions. So you could do this real simply just by saying, okay, there's 20 paces east, another 27 paces east, 40 paces west, and my resultant on this axis at least, it's just adding and subtracting, that would be 7 paces. And then I could also do this for my north and south. So this would be about 34 paces north. Got my 11 paces south, and then another 2 paces south. That means my resultant going from the tail of the first to the tip of the last would be 21 paces north. Now, that's if they're all nice and neatly organized. What if they are not? Well, then we could always realize that if we do north, south, east, west, this is the same thing as saying 0, 90, 180, and 270. Now, how is that useful to us? Well, if we are to list out these values that we are already underlined in green, I could say 20 paces at 0 degrees, 34 paces at 90 degrees, 27 paces at 0 degrees, 11 paces at 270 degrees, that one would be the south, 40 paces at 180 degrees, the west, and then finally 2 paces at 270 degrees. Okay, that's south. Now, I could not simply add and subtract these like regular numbers because even though some are on the X, some are also on the Y. So what I would need to do is break these up into the X and Y components. So here's my X and here is my Y. If I remember from before, in order to get X, that would be using the cosine function. Cosine theta equals X divided by R. That's the adjacent over the hypotenuse. So that means X equals R cosine theta. So tapping into my calculator, or I could just realize it and say, hey, 20 on the x-axis, right? Okay. If I wanted to, I could say 20 times the cosine of 0, and I'd get 20 still. On the y component would be 0. Okay, once again, I could use the trig functions if I wanted to. Some folks aren't quite as comfortable with the trig functions. The y component is equal to r times the sine of theta. So I'd be saying 20 times the sine of 0 is going to give me 0. Anyhow, I can go ahead and go through all these. 34 cosine 90 is going to be 0. 34 sine 90 is going to be 34. Move along through these. That's 27 and 0. Here's an interesting one. 11 cosine 270 is of course going to be 0, but 11 sine 270 is going to be negative 11 because it's going downwards. That's, remember, the south one. Okay, 40 cosine 180 is going to be negative 40, and then the y component is 0. And then finally, 2 cosine 270 is going to be 0, but 2 sine 270 is going to be negative 2. Now, I've got all these little x's and little y's. What I need to do is get my big X and my big Y. My big X, I just have to say 20 plus 27 minus 40 is going to be 7 is my big X, and my big Y is going to be 34 minus 11 and then minus 2, and that's going to be 21, which is the same values I got as over here. Anyhow, now I just have to combine these. This is my 7 paces, this is my 21 paces, and my resultant would be right here. I use the Pythagorean theorem here. That's x squared plus y squared equals r squared. R is equal to 22.14 paces. And then because I have my x and my y, I'm going to use the tangent of theta. But in this case, I want the arctangent, so that means theta equals arctangent, or tan to the minus 1, of y over x, or tan to the minus 1, 21 divided by 7. Tap that into my calculator, and my resultant angle would be 71.56. 71.56 degrees. So my final answer, and I'm running out of space here, is going to be 22.1 paces at 72, man, my 2's aren't working out, 72 degrees north of east.